Okay, the final topic in this unit is the topic of binomial probability. Now, please remember that we have not yet done any binomial probabilities, so that does not mean by any stretch of the imagination that every problem you're going to see in everything you do is binomial. Lots of students make that mistake that once they've done this topic, they turn everything into a binomial problem. That is not at all the truth of the matter. If you're going to have a binomial probability situation, you have to meet three different topics or qualifiers. The first one is that each trial is independent. Now, remember, independent means that one outcome cannot affect the next outcome, and that one can't affect the one after that, and that can't affect the one after that, etc., etc., etc. Okay? So first thing, you have to have independence. The second thing is that you can put the outcomes into two categories, and those two categories are success and failure, just like we talked about with odds. So that doesn't mean if you have, five different colors of M&Ms, and you say, hey, I need a red M&M, that because there are five M&Ms colors, that's not two categories. There really still are. There's red and there's not red. It doesn't matter whether that's a brown, a yellow, an orange, whatever. It's either red or it's not. So there's your success and your failure. And then the last thing is the probability of success has to be the same for every trial. Okay? All right, so what we're going to do next is we're just going to look at four different scenarios, and we're going to simply decide if they are binomial scenarios or not. So remember, what we need to do is keep in mind those three bullet points from up above. They have to pass those three tests. So for A, you roll a die and you want to find the probability you roll a 6 in 2 of your next 5 rolls. So first thing, are those rolls independent? So is the roll that you take on the first die, does that have anything to do with the second roll? Does that outcome affect it in any way, shape, or form? And the answer should be absolutely not. Whatever you roll on a die is completely and utterly independent of what happens next. So it's independent. Can we define a success and a failure? Okay, well, yes, we can. We can say we roll a 6 or we don't get a 6. So there's a success and a failure. We can check that one off as being correct. And then the probability of success is the same for every trial. So what's the probability of rolling a 6 every single time you roll a die? Well, it's 1 out of 6. It's not going to change based on another roll of a die. Still, one side out of the 6 show a 6. So in this case, we've met all three qualifications, and this is indeed a binomial situation. Okay. All right, part B. You want to find the probability of drawing 2 red cards from a deck if you do not replace the card between draws. Okay, so in this case, because there's no replacement, we do not meet this independent situation, because what happens on the first draw, okay, let's say you draw a black card out, that does impact what happens next because you took a black card out of the deck. If you drew a red card out of the deck, it impacts what happens next because you're starting with a different deck, so to speak, than what you did at the beginning. Originally, you had 52 cards, and then you had 51. That also goes against that last bullet point. The probability of success is the same. Once you remove a card, the probability isn't the same anymore because your sample space has changed. Okay, so same probability, that's also a no. And so this is not a binomial situation. We would not be able to solve this using binomial techniques. You want to find the probability of rolling a 4 on a die and then getting heads when you flip a coin. So is this independent? Yes, absolutely it is. Flipping a coin and rolling a die have nothing to do with each other. One outcome will not impact the other. Can you put those into a success and a failure? Well, sure. A success is a 4. And a head, and then a failure is anything other than a 4 and a tails. So we can get through the success and failure probably okay and decide we can do that. But then the probability of success is the same for each trial. Well, the probability for rolling a 4 is 1/6. And that is not the same as the probability of getting heads on a coin, which is 1/2. Those probabilities are not the same. So this is not binomial. Okay, and last but not least, the flu shot is 60% effective. What's the probability at least 2 of the 3 people in my house don't get the flu if we all get the flu shot? So is it independent? So does whether or not the flu shot works for me have anything to do with whether or not it works for my child or my other child? Absolutely not. Okay, flu shots are independent. Can we put them into 2 categories, a success and a failure? Yes, indeed we can. We either get the flu or we don't get the flu. So we can put those into our 2 categories. And then last thing, is the probability of a successful or an effective flu shot the same? Yes, it absolutely is. The flu shot is 60% effective for every single person who gets it. So this would be a binomial situation. In the next set of notes, we will talk about how then you actually calculate a binomial probability once you have determined that your situation calls for it.